Welcome to Maths for All. I'm Aisling Flynn. This is Statistics 1.9, the normal distribution and empirical rule. Okay, so here we have on the left a picture of a symmetrical histogram and a curve, or what's called a bell curve, shaped like a bell, fitted around it. Okay, so if a large enough study is done and enough bins or bars on the histogram can be made, the histogram begins to look like a curve. Okay, and this bell curve that we see is known as a normal distribution. The normal distribution. The normal curve is a smooth, bell-shaped, symmetrical curve. The central line is its axis of symmetry, so left is the same as right. Okay, and the mean, the mode and the median of the data that made this curve are all equal, and they lie on the axis of symmetry. Now, normal distributions occur frequently in nature. For example, if you were to record the heights of men in Ireland, firstly, you'd have lots and lots and lots of data. Okay, you would have most of the people would be towards the center of the graph, which is what gives it its high peak. Okay, and then it tails off to the left and the right, demonstrating that there are a small number of very, very short people and a small number of very, very large people. So when you do really large studies, often the result is a normal distribution. If you were to record the circumference of trees in a plantation, say they're all planted at the same time, some are slightly larger, some are slightly smaller, okay, and if you had enough trees you would get this nice smooth curve for your histogram, okay, which is the normal distribution. If the IQ of all 18-year-olds was recorded, you'd get a normal distribution, etc. Okay, all normal distributions will have a mean, which is given the letter mu, and a standard deviation, which we saw was sigma. Different values for mu and sigma will give different normal distributions. Okay, so the diagram on the right shows two normal distributions. They have the same mean, but different standard deviations. So let's look at the green curve first. It has a mean of 20, so the peak is above 20, and it has a standard deviation of 5. Okay, so on average the values are within 5 of 20. Okay, so alright, so it's quite a narrow curve. They're quite close together, so it's a tall, narrow bell curve, but it is still symmetrical and it is still a normal distribution. Let's look at the blue curve. It also has a mean of 20, so it's centered around 20. Its peak is there, but its standard deviation is 10. Okay, meaning that on average the values are 10 away from the center. So that means that the blue curve is much more widely spread out. Okay, and for that reason the peak is also lower because the values are spread out to the sides left and right, but it's still symmetrical. You still have 50% below 20, 50% above 20, and it's still a normal distribution. This diagram shows two normal distributions with the same standard deviation but different means. Okay, so the green curve has a mean of 20, so its center, its peak is above 20. And it has a standard deviation of 5, so that's the width that we saw on the previous slide. The blue curve has a different mean. It has a center of 30, and its peak occurs right above 30, but its standard deviation is 5, so spread-wise or width-wise it looks the same as the green one. It is just shifted up the axis a bit. So both normal distributions. Now, the empirical rule is what we're going to look at next. What it does, it describes the normal distribution, and it defines what proportion of the data will you find close to the mean and further out and towards the end. Okay, and this rule applies to all normal distributions, whether they are tall and thin, or whether they are short and broad. These proportions apply to all. Okay, so all normal distributions share some very important characteristics. About 68% of all the values in a normal distribution are within one standard deviation of the mean. So the vast majority of data will be close to the mean. Some a little bit below, some a little bit above it. Okay, so the definition here says that 68% of the data will be within one standard deviation of the mean. So that is here, this line on the left, which has the mean minus the standard deviation, and the line to the right, which has a mean plus a standard deviation. So between those two vertical lines, 68% of the data will be found. Okay, and 34%, so half of 68, 34 will be to the left or below of the mean, and 34 lie to the right or above the mean. So it's all symmetrical, and we break the normal distribution up into these sections for the questions we're going to do later. So for all normal distributions, about 95% of all the values in a normal distribution are within two standard deviations. So we've moved further out from the mean. We've stepped out 2 standard deviations below, which is this vertical line on the left, up to 2 standard deviations above the mean. So that's the vertical line on the right. Now between these two lines on the normal distribution on this histogram, you will find 95% of all the data. Okay, and if we split that 95 symmetrically about the mean, so the mean is down the middle, you'll find 47.5% to the left or below the mean, and 47.5% to the right or above the mean. And generally, values that lie outside this range are usually considered to be outliers. So if you had a value down here, it's very, very small, it's outside of our purple zone here, and it would be an outlier on the small side. Okay, or up here you would have large outliers, so values that are much, much bigger than the general data. Okay, and let's step it out one more standard deviation. Almost all, so 99.7% of all the values in a normal distribution are within 3 standard deviations of the mean. So between those lines. Anything outside of that is exceptional. So again, you can split your 99.7 in 2, divide by 2. You'll have 49.85% of the data below the mean and 49.85 above. Okay, so here we have a single diagram that gives those 3 different pieces of information. So what you need to memorize are these 3 figures. For 1 standard deviation left or right, that gives us 68%. 2 standard deviations gives us 95%, and 3 standard deviations left and right gives us 99.7% of the data. So take a moment and learn those 3 figures. Okay, so this diagram is nicely split up into different sections. Okay, so we get the 34 and the 34. Okay, that those two combined left and right gives us 68%. So where did the 13.5 come from? Okay, so recall that for two standard deviations left and right, we had 95%. Now if we split that into two as we did previously, you would get 47.5% to the right and 47.5% to the left. Now if you do 47.5 minus 34, it's going to give you the 13.5, so that's where that comes from. And equally, when we divided the 99.7% by 2, we got 49.85 for the left and right. So if you subtract from that 47.5, you get your 2.35, those two yellow sections. Okay? All right, so we're going to do some questions based on that and we'll see how it is. Okay, first example, the marks out of 100 in an examination are normally distributed. So as soon as you see this word here, normally distribution, you must recall your three values, 68%, 95% and 99.7%. Write them down at the top of your page. Okay. The mean mark is 60. Okay, so we're going to definitely need that value, 60. And the standard deviation is 6. Okay, number 1, work out the mark that is 2 standard deviations above the mean. Okay, so, well, that's straightforward. You start with your mean, which is 60, plus 2 times 6, which is 12. So 2 standard deviations above the mean, we get 72. Okay, so that's number 1. Number 2, what percentage, so we'll answer must be a percentage, of the marks lie between 48 and 72. Now we know what 72 is. It's 2 standard deviations above from part 1. So let's explore what's 48. Okay, so if we do 60 minus 6, that's 1 standard deviation, we get 54. If we do 60 minus 12, or 2 standard deviations, we get 48. Okay, so this is what we have. Quick sketch if you wish. You don't need it though. So normal distribution, our mean is 60. 2 standard deviations above is 72 and 2 standard deviations below is 48. So what figure do we use? The question said what percentage of marks lie between 48, 2 standard deviations below, and 72, 2 standard deviations above. Well, here's our 3 figures. 1, 2, 3. So we choose the second one is for 2 standard deviations. The answer is 95%. So you can just write it down. Okay. Now, here it gets a bit trickier. What percentage of the marks lie between 60 and 72%? So 60 and 72, and this is where a sketch comes in handy. So 60 is the central mean mark, and 72 was 2 standard deviations above. So I've shaded in the area of the distribution that they're referring to. So it is just the right hand side we're looking at, from the mean up to 2 standard deviations. So that's half of the 95. So 95 divided by 2, and that's 47.5%. Okay, again the question said what percentage, so your answer must be a percentage. Okay, now Question 4. If 1,000 students took the examination, how many students scored less than 54 marks? Okay, so where is 54 on our diagram? So it was mentioned up here. 54 is one standard deviation below 60. So there's 54. Okay, so 54, we want to know how many, basically we need to find the percentage first. What percentage of students are below or less than 54? Now I'm going to draw a new diagram. So sketching is always good. Okay, 60 is in the center. 54 is here. It's one standard deviation below. Okay, so for one standard deviation, the figure is above and below is 68%. So this between these two vertical lines is 68%. We, however, are not interested in that. We're interested in this left-hand tail of the graph. So what percentage is in here? Okay, and the easiest way I know to do that is, well, let's just write in what we know here, 34 and 34, is to take away the remainder of the graph. Okay, so if I take away the whole left-hand side, or whole right-hand side, I am taking away 50% of the graph. And then if I take away 34%, I take away that bit, and whatever is left gives me what I need, the left-hand tail of the graph. Okay, so I'm going to start with 100%. We're going to take away the whole right-hand side, and we're going to take away the 34% between 54 and 60. Okay, and that leaves me with 100 minus 50 minus 34. That leaves me with 16%. Okay, so 16% of students score below 54, and we have to find 16% of 1,000 students. So however you do your percentages, and you're going to get 160 students. Okay, so pause the video there, go back through the diagrams. Mine are all scribbles. You should take a page and draw your own. Okay, figure out, where did I get the 50% from, where did I get the 34% from, and what's left over. Okay, and that's number 4 done. Okay, another example. Bottles of 300 milliliter shampoo are filled with the amounts in the bottles normally distributed with a mean of 30 mils and a standard deviation of 3 mils. Okay, if 10,000 bottles are filled, how many bottles contain amounts that are within one standard deviation of the mean? Okay, so we see the words normally distributed. So before I forget them, I'm going to write down my 3 figures: 68%, 95%, and 99.7%. Okay, question 1 is looking for how many bottles within one standard deviation of the mean. So one standard deviation above and below refers to 68%. Okay, so question 1 will get 68% of 10,000. So 0.68 times 1,000, or 10,000 rather, count your zeros, and we get 6,800 bottles. So more than half, 68% of them. Okay, now let's look at question 2. How many bottles are more than 2 standard deviations above the mean? Okay, so we will be using our 95%. That's for 2 standard deviations. Okay, but it says more than 2 standard deviations above. So in this case, we're going to sketch a diagram. Okay, our mean, we were told, is 300. Standard deviation is 3, so this would be 303 and this would be 306. Now, we want to know how many are more than, so we're looking at the right hand tail. Okay, and because we're not sure where the tail ends exactly, what you do is you work with the rest of the graph first. We take it away. Okay, now I can, to get the tail left over, I'm going to take away all the left hand side of the graph. Okay, it's half of the graph, it's 50%. And then I'm going to take away the part of the right hand side up to 2 standard deviations above the mean. Okay, and that would be half of 95%. Okay, and we saw that that was 47.5%. Okay, and what's left over will be more than 2 standard deviations. So let's take our 100% of the graph, let's take away the left hand side 50%, and let's take away the right hand side up as far as 2 standard deviations above, and you're left with 2.5%. So 2.5% of the bottles are more than 2 standard deviations above the mean. So we get 2.5% of 10,000. So we get 0.025 by 10,000. Which is 250 bottles. Okay, so again, stop the video, draw your own diagram and review where the numbers 50 and 47.5 came from. Okay, that was the second one. Number 3, if the manufacturer rejects bottles that contains amounts more than 3 standard deviations from the mean, what is the largest amount of shampoo in a bottle you would find for sale? Okay, so 3 standard deviations above or below he rejects. So let's draw a sketch, a diagram, and put in some numbers. Okay, so 300 is in the center. 1 standard deviation above, standard deviation was 3 from our question up here, is 303. 2 standard deviations is 306 and 3 standard deviations is 309, and it would be the same lower, but the question asks what is the largest amount of shampoo you would find for sale in a bottle. The largest one, 3 standard deviations above the mean, is 309 milliliters. Okay, now another example. The weights of a group of 1,000 school children were normally distributed with a mean of 42 kilograms and a standard deviation of sigma. So they don't give us the standard deviation here. If 950 of the children were in the range 30 to 54, find the value of sigma. Okay, so our mean is 42. Mean is 42. We don't know sigma. We have a range 30 to 54. Okay, but the other information we have is 950 out of 1,000 children. Okay, so that's something we have to work with. Okay, so remember, for our normal distribution and empirical rule, we use percentages. Okay, between the standard deviations. So we need to find a percentage. Okay, what percent of children, 950 out of 1,000, lie between that range? So that's 90, that's a fraction, and you'd multiply by your 100 to give your percentage. You get 95%. Okay, so normally distributed, we have 3 figures: 68%, 95% and 99.7%, and we're dealing with the middle one here, which is plus or minus 2 standard deviations. Okay, so 30, if I'm going to draw a little sketch here now. Alright, we're told that our mean is 42, and now we know, because of the 95%, we know that 30 is 2 standard deviations below, and that 54 is 2 standard deviations above. Okay, so what's the difference between 30 and 42? Well, that's 12, and it's another 12 up to 54. So what's 1 standard deviation? Sigma is equal to 6. Okay, so half of the 12, because that was 2 sigma. Okay, so working it out, you do need the percentage to figure that out. Okay, number 2, find the probability that a child selected at random was in the range 36 to 48. So where is 36 and 48 in the scheme of things? Using our sigma, now we know a 6. Well, if we do 42 minus 6, we get to 36, and 42 plus 6, we get to 48. So the question is asking, what's the chances of choosing a child in this region? And we know for 1 standard deviation above and below, the figure is 68%, but for probability we'd say it's 68 out of 100. Okay, we could simplify that fraction, leave your answer as a fraction, which is 17 in 25 chance, or you could write it as a decimal, it doesn't matter, 0.68. Okay, so there you have that. Pause and review. Now you try some questions on this, statistics 1.9, the quiz, and the written exercises.